Hi everyone, I have an update here. And Hi everyone, I have an update here, and I'd like to show you what I have found so far. So here's my 400 watt Coleman inverter, and it has an 800 watt peak surge, and it's just attached to this deep cycle 100 amp or 115 amp hour battery. And the output, I just have a plug here, and the electrical plug is going to a full wave bridge rectifier. The full wave bridge rectifier is just connected the same way as it would standard be. So the wave on this side, and on the red wire here is my positive, and the black wire here is my negative, which is going to this capacitor. That capacitor there is 150 microfarad 400 volt capacitor, and I don't have the red positive connected to the capacitor continuously, because that's not working for me at this time. And all I'll be doing is charging the capacitor, releasing it, and then igniting the coil with this red wire here. And I've got these little neo magnets here to make a nice clean contact for when I touch the fine little copper wire on the magnets there. So this red wire is going to the positive of the capacitor, and that is the positive of the coil, and the negative of the coil is going again back to the negative of the bridge rectifier. The negative of the bridge rectifier is going to the base of the spark plug here, which is I have these vice grips holding on to it, and the positive here is coming out of the ignition coil, and I've got a small diode here. That's just an N4007 coming out to keep voltage just going in one direction towards the plug here. And I've got another wire here, and what I've got is a microwave diode here, microwave oven diode, and that again is also directed to the positive. So it's very, very simple, positive to positive. And this diode here is the one that I believe is going to lead in the radiant energy. I don't believe this is a capacitive discharge process. I believe after seeing all that radiant energy flame, that is actually what will be breaking the water apart. And I'm kind of getting results on that to show. So I've got really no capacitor banks that I'm loading up here, and I don't think it's about that. I think conventional electronics is really not going to be what's going to make this particular system work. It's most likely that radiant energy, or whatever, that flame that I've already done the video of, that is going to break it apart. So this capacitor here is only used really to trigger the high voltage out of the coil. So it's not a reserve or anything, and it's a small capacitor, probably can be much smaller. What I'm doing is I want everybody to start thinking about this, trying to get this effect and improve it. I'm not the best at electronics. It's not really my field. So really I just want to post this so that people can all start working on it and get this working. So let me show you what I've got so far. Just place the camera back here, and could see that, the spark that's happening. Okay, I'll try to get that wire out of the way there. So I do a very small squirt, very fine mist, and I'll turn on the inverter, and I charge up my capacitor. Capacitor's charged, and now I discharge the capacitor. Whoops, that water out of there. And there you go. That is what I believe it's about. Charging my capacitor. That little click you hear, that's the capacitor being charged. And I squirt it, and bang. You see the flame? I'm doing this without capacitive discharge. Again, charge my capacitor, discharge. See there? The water's gone. A little bit of water. It has to be the right combination of water too. I can flood it. There you go. There's a nice one. Charge my capacitor again. And there, it's gone. So obviously all that water got blown up. Charge the capacitor, discharge again. Alright, so it needs water for it to work. I'll show you. I'll charge the capacitor again. Okay, there must have been a remnant of water there. Charge the capacitor again, discharge. Charge, discharge. Charge, discharge. Well, I'm getting a good spark now. But it's not a red spark. As soon as I introduce a bit of water, you'll see that it's different. There you go, you see that red flame? So it's the high voltage that's triggering, that's allowing the path for that radiant energy to come through. And this is hardly taking any energy from the inverter. It's not even squeaking. Put a bit more water on it. I think the results would be probably a lot more clearer in the engine. I think it needs the compression and all that. And I have a lawnmower motor that I'll soon try it in. This may be just the circuit, because if you think of the demo video by S1R, whatever his name is, he has it hidden, and I find that when you hide things, that usually indicates that, you know, it's pretty damn simple. And what I have here is pretty damn simple. So there you go. And I'll just bring out the camera a bit so you can see what I'm doing with the capacitor here. Just charging the capacitor, discharging it, charging it, discharging it, charging it, discharging it. Now it's the radiant energy that is doing the work. It is not this capacitor. This capacitor is only 150 microfarads. It's only capable